In this video we will look at how to receive and validate data using a slave AXI4-Stream Bus Functional Model from the UVVM Light library. In a previous video we set up a simple test bench to generate data using an AXI4-Stream Bus Functional Model, BFM, from the UVVM Light library. In this video we will expand that test bench to include a slave interface that receives and validates the data sent by the master. We start by adding a record for the slave AXI4-Stream interface, as well as an array that will serve as our expected data. For our first test, the expected data will be identical to the data sent by the master AXI4-Stream interface. Next, we will add the configuration constant for the slave interface. This configuration is identical to that of the master interface, with the exception that in the slave interface we set the ready signal to be driven low randomly throughout the transmission of the data. We now connect our master and slave interfaces to each other. In a real-world test bench, the interfaces would be connected to a design under test instead of to each other, but for the purposes of our demonstration, a design under test is not required. The logic for generating the AXI4-Stream data remains unchanged, so we are ready to add the code for checking the data with the slave interface. Because the UVVM BFMs are blocking, we need to add a separate process for this purpose. The UVVM AXI4-Stream BFM package offers two options for capturing data: the AXI4-Stream expect procedure and the AXI4-Stream receive procedure. The AXI4-Stream expect procedure takes mostly the same parameters as the AXI4-Stream transmit we used earlier, with two key differences. First, instead of the data to be transmitted, we must indicate the expected data against which the received data will be compared. Second, we must indicate the severity level with which mismatches between the expected and received data will be reported. We use warnings in this example so the simulation can continue after finding the discrepancies in the data. We can now run our simulation. This time, instead of compiling the libraries and linking them to ModelSim in a separate step, we will compile the UVVM Light sources together with our test bench code. This not only makes it easier to run this example by removing the previous compilation requirement, but it also enables us to parameterize the UVVM packages to fit our needs. The commands to compile the UVVM Light sources are taken from the UVVM owns compilation script for ModelSim and Questa, which is available in the script folder of the UVVM Light repository. There are three sets of files that must be compiled: the utility sources, the BFM sources, and our test bench source. The waveform shows that the slave BFM randomly deasserts its ready signal. Together with the random deassertion of the valid signal by the master interface, the UVVM BFM allows us to model the ready valid handshake of the AXI4-Stream protocol with minimal effort. In the simulation logs we can see the confirmation from the slave BFM that the received data matches the expected data. Of course, we knew this would be the case because we used identical arrays for the master and slave interfaces. We now rerun our simulation after changing two or more values in the expected data array, and we can see that the slave BFM reports the mismatch. We can notice two interesting behaviors here. First, the AXI4-Stream expect procedure reports the number of mismatching bits between the received and expected arrays. It does so by flattening the arrays and comparing the bits one by one. One disadvantage of this approach is that it removes the word-based abstraction. That is, it is not possible to know at first glance which and how many words in the received array differ from the expected values. Second, the AXI4-Stream expect procedure only reports the index of the first mismatching word in each AXI4-Stream packet. This can make it difficult to find patterns during the debugging process, because we would have to fix each error one by one. If we would like to have more control over how the received data is checked against the expected data, we can replace the AXI4-Stream expect procedure with the AXI4-Stream receive procedure. In this case, the BFM returns an array with the values sent by the master interface, but it is up to us to compare that data with the expected values. This gives us a much higher degree of control over how the checking is made, but it requires us to implement more custom logic. The simulation transcript now shows one warning for each of the mismatches found in the AXI4-Stream packet, as well as the index of each mismatching word. This would be much more useful in a real-world debugging scenario. Regardless of whether we choose the expect or receive procedures, having a readily available BFM for sending and capturing AXI stream data is a great tool in our verification arsenal.